Hi guys, this is the video about projectiles. We'll look at first where the equations come from that we can use, and then we'll look at three example questions that build up in difficulty of how to solve the problem. There's nothing really new about the maths that we're going to do, apart from where the equations come from, but from that we're just going to integrate anyway, which you know how to do. And the equations we use will come out to be a quadratic, which we'll need to solve. So nothing new there, I hope. And also I need some trigonometry, or we may need some trigonometry. And if not, you usually have to resolve into components to figure out what the upper, the vertical and horizontal parts of any motion is in the projectile. So let's first off start off with where do the equations come from? Okay, so the two equations that we generally use are what I'm going to derive first. We won't need anything else for that today. And I'll just start off with a kind of basic reminder of if you integrate something, what do you get? So if you integrate 5 dx, like that, 5 dx, then you'll get 5x plus c, of course, 5x plus c, yeah, which I'm sure you're more than familiar with. Let me just reset my pen because it's not writing very well. Okay, so why is that? Well, because if you've got a graph just very roughly drawn there, and that's the line y equals 5, then the area underneath that will be 5 times by x, which is of course a rectangle. So as it goes along, it sweeps out this area one at a time, which will sum up to 5 times whatever the x value is. So if x was 10, the area would be 50 or whatever. But in general, it'll be 5x. Okay, so if we then change that to 5 dt, the answer will be 5t plus c, because we're summing up all the c's, which change the axis to be up to one where the x-axis is now a t-axis. And if y is 5, then the area underneath this will be 5t instead of 5x. Okay. So we can generalize this even further by changing the number to a letter, which represents a number. So if we call that a dt, that will be at plus c. Like it was 5t before, now it's at plus c. Okay. Now in mechanics, a stands for acceleration, which just means a change of speed. So if you change your speed, you've accelerated, or direction. But for now, let's just think of it in terms of speed. So if you, that can mean if you're at rest. So if you're at rest and you increase your speed by 1 meter per second squared, or 1 second, you'll go to a speed of 1 meter per second because you increased your speed by 1. So if you went from 0 with a rate at 1, you're going to have a speed of 1. So acceleration will be the rate of your change of speed. So increasing by your speed by 1 every second will, after 1 second, increase your speed to 1. So you start off with 0, accelerate at 1 meter per second squared. That means that you'll increase the rate of change of your speed is 1. After 1 second, you'll do 1 meter per second. Now, if we take a lot of these accelerations and we slow down, speed up, slow down, do different amounts of acceleration, deceleration, and add them all together, we could sum them all up. And a sum, of course, is the integral. So we sum them over time. And this is what we've just done here. We just integrated all the accelerations over time. And that will tell us our velocity. So v is at plus c. Velocity is at plus c. What's c? Well, c in our example was 0 because that was our initial velocity. We started at rest. Well, if it's not that, it could be anything really. Doesn't matter what it is. So c would be the initial velocity, and we write it in reverse order, which is a bit strange because we kind of put the gradient at the end. where we consider the initial velocity first, and it's going to be a straight line for a constant velocity. So it looks something like that with a positive velocity. We're starting with initial velocity u and the gradient of a, and the velocity is dependent on time. So if you're continuing to accelerate constantly, the longer you do that, the faster you go. That's all that equation says. So the longer you do that, the higher the speed will be. Okay, so we've done that. So let's now take v equals u plus at and integrate that. So scroll up to there. So v equals u plus at. So if we integrate all our changes of speed, then what that will do is tell us how far we've gone. Because a speed, it just means how far have you gone in a unit of time. So when we say 60 miles per hour or 60 kilometers per hour, that means in 1 hour we'll go 60 kilometers. So really we're talking about distance. And we're saying, this is how far I've gone in this time. So this is a change per step, which hopefully you'll be familiar with, you guys. So if I add all those changes up, I'll get my total distance. So if I do 10 minutes at 70 miles an hour, then 10 minutes at 30 miles an hour, and so on, I can sum those all up. So an example of that is the odometer in your car. It just adds all the miles up, doesn't care how fast you do them. It just sums all the distance to them. So if we integrate this u plus at, which means velocity, it'll tell us the sum of all the velocities and therefore the total distance. So u will become ut, at will become at squared divided by 2 plus c. So that would be our total distance. The letter we use for that is s, although we call it displacement in mechanics. Now the plus c in A level is effectively the starting point. Okay, so just like it was for velocity, so if you start off at a sort of coordinate 0, 0, c will be 0. And at A level, we actually do that anyway, so you'll never see it. Technically, it should be really sort of SO, initial starting point, whatever that position was. But at A level, it's always kind of generally guarded that wherever you start from is 0. So that means we never use that. So there are our two equations. S equals ut plus half at squared, and v equals u plus at. That's meant to stay with u. So v is u plus at. Okay. So the problem there is we can find what the displacement will be, what the velocity will be. Acceleration is quite a simple equation, a equals a, which is just each one differentiated. So we differentiate s, I get v, and we differentiate v, I get a. So we could have another list of equations which says that v, let's do it here, v is equal to ds divided by dt, and a is dv by dt, which is actually a second derivative of the function s. Okay, so hopefully all that makes some sort of sense so far. It's stuff that we've covered before, and hopefully it kind of jogs your mind jogs your memory as to where those equations come from. Our s equals ut plus half at squared, hopefully that was also familiar to you because that's a quadratic. We've got a t squared term. So this is going to be parabola in nature. And so it gets used for projectiles because projectiles follow parabolic curves. So this equation describes how far, either range-wise, horizontally, how far the projectile goes, or how high it goes, depending on your values of u and a. So I'll look at that in the examples. Okay, so talking of examples, let's have a look at one. So our first question will be this one. Not that one, that one. So a pellet is fired vertically upwards at a speed of 11 meters per second. No air resistance. What speed does it hit the ceiling 2.4 meters above its point of projection? Okay, so let's make a note of those numbers. So we've got vertically upwards at 11 meters per second. And I want to know what speed when the basically S is equal to 2.4 meters above. Okay, so let's figure that out. So let's go back to the whiteboard for that. Normal practice for these kind of questions is to use or write down what values these 5 things take. So SUVAT it's called, and so S, we want to know what's the value going to be at 2.4 meters. U is the initial velocity, which is meters per second. V is what we're trying to find. A is going to be minus G, because if you throw something up, the only thing that's going to be slowing it down is gravity. And that's got a value of minus 9.81 meters per second. So if it was thrown up at 9.81 meters per second, it would, after 1 second, come to a stop because it decelerates that quickly. And T, don't know T. So how are we going to figure this out? So the question asks, calculate the speed at which the pellet hits the ceiling 2.4 meters above the point of projection. So basically what we want to know is, after 2.4 meters of this, what speed is it going at? Okay. So we can try and figure out what time is, how long does it take to travel 2.4 meters? Okay, so how to do that? So if S, actually, there's a kind of third way we could do this, which I'll do now and see if we can integrate time into it. So we could use a further equation which eliminates time completely, since we don't have time, which is v squared equals u squared plus 2as, which is actually just a combination of the 2 previous equations combined, where t is substituted into the other. So v squared equals u squared plus 2as. And we're trying to find v, aren't we? So why don't we just use u squared plus 2as to find that? So u squared is 11 squared, which we know well, times by 2 minus 9.81 times by 2.4. So because it's going to slow down, the speed will be less than 11, won't it? I would imagine. So that's why it's going to be a minus sign. So 11 squared, 121, but minus some amount, depending on the acceleration, how much it slows down by, and how far it's gone. So that's what this equation says. So 121 minus 2 times 9.81 times 2.4. So calculator for that one. Yeah, I'll be lazy and get the calculator out. So 2 times 9.81 times 2.4, which is 47.088. So, right, okay, take those away from each other. And we get 73.912. And we'll square root that to find the velocity. So the answer is going to be 8 and a bit. So square root that, we get 8.59 meters per second. So I'll call it 8.6 meters per second. Oh, you can't see it. There you go. That's it. So in that case, because I didn't have time, I thought, I don't want to actually use any of those 2 equations. So this equation, v squared equals u squared plus 2as, is just those 2 equations are thrown together and eliminates time. I won't go through the algebra of that, but essentially you just substitute v equals u plus at into s equals ut plus half at squared, and solve the squares. And it comes out as that. Okay, so we found speed. It's obviously, when you throw it up, it's going to be slowing down. It's going to hit the ceiling at 8.6 meters per second. Cool. Let's have a look at the second example, which is, I'll just share it now. So there we go. So this is where I need to use trigonometry. So a football is kicked with speed 31 meters per second at an angle 20 degrees to the horizontal. It travels towards the goal, which is 50 meters away. Okay, so it's kicked at, I was going to draw this while I'm sort of speaking. So it's 31 meters per second at an angle 20 degrees. And the goal is 50 meters away, so I've got a distance for that. And the height of the crossbar is 2.44 meters. Does the ball go over the top of the crossbar? So we've got quite a bit of work to do there because it's a 6-part question. And then state one assumption you made in answering part 1. So they often ask this. This is just means, think of things like the air resistance, spin on the ball, wind. So it's assuming this is acting in a vacuum, which would be impressive to play football in. Okay, so we've got to think, does the ball go over the top of the crossbar? Okay, let's figure that out. So I think the first thing we need to do for this is calculate the time of flight. How long is the ball in the air for? So normally the practice is to have a look at what's going on horizontally and what's going on vertically. Because I've got the horizontal distance, if I can figure out what the horizontal speed is, I can figure out the time it takes to get to the goal. So let's have a look at that. So V equals U plus AT, and S equals UT plus a half AT squared. These are the two equations that I want to be using to find the information. So first thing is, what's the horizontal speed? Right, so we need to think of that as a triangle, as usual. So this is 31, and this is 20 degrees. So the horizontal component of the speed will be the base of the triangle, or the width, which means use cosine. So 31 cos 30 will be the horizontal component of the speed. So cos 30 is root 3 over 2, so it's 31 root 3 over 2 meters per second, which, let's change that to a decimal. So just quick calculation, 31 times root 3 over 2. Again, notice the nice number, cos 30, so you kind of expected to know these without having to use a calculator. So 31 times by root 3 is 53, and then divide by 2, so 26.84 meters per second is the horizontal speed. Okay. Now I know it goes 50 meters, so I can figure out how long it takes to get there now, because we can use the other equation, S equals UT plus half AT squared, but A is 0 horizontally. You know, it doesn't speed up, doesn't slow down horizontally, just going towards that goal, because the two parts of the flight are independent of each other. The vertical part and the horizontal part are independent. So as it flies as it goes horizontally, we can just use S equals UT, and we're trying to figure out T. So T will equal S divided by U. So the distance, which is 50, divided by 26.84. So you can see it's going to be a fraction less than 2 seconds. So it's 50 divided by 26.84 is 1.86 seconds. Okay. So we know that the ball is in the air for 1.86 seconds when it gets to the goal. The question is it going to be above or below? So what we could do is just use the vertical component of the equation to figure out the height at that time. First, though, we need the vertical speed. So the vertical speed will be 31 sine 30, which is just half 31, so it's 15.5 meters per second. So using S equals, let's make sure you can see that. So 31 sine 30, 15.5 meters per second. So S equals GT plus a half AT squared. We're going to use S is equal to 15.5 T, which is 1.86, minus a half, which is a half A, which should be 4.905 times T squared, which is 1.86 squared. So whatever this comes out as will be the height of the ball at that time. Okay, so we've got to do 1.86 squared times 4.905, which is 17.02, and 15.5 times 1.86, which is 28.83. So if my calculations are correct, which it seems quite high, the answer is 11.87 meters, which is more than enough to get over the goal. So that seems like a bit of a long way off compared to, you think it'd be a bit more tight than that compared to the question. So maybe I've made an error somewhere, but my approach is correct, and I'll state that at that point, it'll be well over the crossbar. A quick look to see if I can figure out if there is an issue anywhere. I can't see it. 9.81, yeah, that's correct. 1.86 squared. Even my calculator's not playing ball. No pun intended. And that's it. And again, going back to what assumption is there. So we know air resistance. This has been a football match played in a vacuum. Okay, so now we'll look at final example. This is a horizontal projection. So here the ball is another ball. A small ball is kicked off the edge of a jetty over a calm sea. Again, no air resistance. Point of projection is O, and you don't have to do any resolving here. So you're given the horizontal and vertical components of 8 and 12 respectively. Okay, so the ball's actually going in a parabolic motion, but it's been given an upward force, upward speed of 8 meters per second, and a horizontal one of 12. This is all taking place 3.6 meters above the sea. And the time elapsed after the ball is kicked is in seconds. Okay. The final expression in terms of t for the height of the ball above O at time t. Now, I used to hate these questions because I used to like it where they just ask me number questions and I put numbers in the formula to get some numbers out. So finding expressions in terms of t is basically what I don't want to see in an exam. However, it's not actually that difficult. It's just, you just need to use the equations that you would use anyway. And determine how far the ball lands from A. Okay. So part one, find the expression in terms of t for the height of the ball. All right, so that means we're just going to use the height, which would be using S equals UT plus half AT squared, because we want, a distance. And we'll just need to put the numbers in appropriately. So if you do the same SUVAT thing, so we'll switch over to our whiteboard. There it is. That's what's going on. So it's being thrown off this jetty. It's actually a projectile motion, a parabola, but it's given this 8 meters per second and 12 meters per second components. And we want to figure out an equation for its height. So we just use the same thing. So vertically, S is what we're trying to find. U is 8 meters per second vertically. V, don't know. A is going to be minus G, and T, don't know. That's what we're trying to find. So it's going to be S is equal to UT, so AT, minus a half AT squared. And there we go, that's our vertical equation. That will tell us the position of the ball for any value of T. It also asks for the horizontal one. The horizontal one, very straightforward, just be S equals 12T, because horizontally A equals 0, because there's no acceleration. Acting horizontally, it's not going to slow down, it's not going to speed up horizontally. So for every second it goes along, it will cover 12 meters. Basically, that's what it's saying, horizontally. So there are two equations. Okay, so if we flick back now to see, well, what did it ask us about that? Determine how far away the ball lands from A. Okay. So what we really need to do is figure out how long does it take to drop 3.6 meters despite the fact it's been launched upwards and away from the sea. That's basically the question. So let me flick back. So how far the ball lands from A? So in other words, what's called the range. So what we're trying to decide is the ball gets thrown, it's going to go like this, it's going to land some distance over here. Okay, and how far is that? That's the question. But from a vertical point of view, all that's happened is it drops 3.6 meters. Okay. So what we could do is figure out how long it takes to get there. And the way we could do that is just set the first equation that we've been told to figure out. So that's always a bit of a hint. To minus 3.6. So we've got minus 3.6 is the height is equal to 8t. So some value of t will satisfy that equation because that's what the height is for some value of t. So we just need to solve it, and hey, we've got a quadratic. So if we take the t squared to the other side and the 8t, we've got some horrible numbers. But we could just figure out what they would be. We could use the quadratic formula, which would be horrible as well. Or I'm just going to cheat and use a calculator. So just for the purposes of this, you know how to solve that quadratic. You use the formula and check it on the calculator. So I'm just going to use the calculator. Okay, so just bear with me 1 second. So yeah, what I could do actually, we could use Wolf Malta. Why don't I do that? So there we go. Lost my whiteboard now. Wait a second, sorry. Yeah, there it is. There it is. I forgot about good old Wolf Marathon. Okay, so share that, and just going to stick that into quadratic. So solve this horrible quadratic, please. 4.905 x squared minus 18. So I'll do an x on this calculator because t or x doesn't matter, does it? Minus 3.6. There it comes out with some absolutely horrible numbers. Thank you, Wolfram Alpha. That's really helpful. Yeah, so let me get that into view for you. So minus that, or that. So it's going to be the second one, because that's how far it went. So it's going to be our second solution. So the positive one, which is 4 divided by 9 at 1 times 200 plus 84145. So let me just look up what that is. Nice. There are horrible numbers, aren't they? Right, okay, so it says 84145, root that, so 490 times by 4 divided by 9.81 times 490. So we get a very large number, 199 seconds. That's so about 3 minutes. That seems a bit of a long time to pick a football. So I did something wrong there, probably. So root 8445. Root so 8445. Let's start again. 84445. So notice there, I question myself. So, does the answer seem reasonable? No. Okay, so that would sort of suggest it not. The 290, so 490, yeah, happy with that. 4, I bet this one. No, yeah. So 4 divided by 981. That's what it is. Times 490, 1.99. There we go. Just put the wrong division in. So 1.99 seconds. So let's call that 2 seconds. 1.997 seconds. It's going to take. There's two solutions, but the one's negative because what it represents is as if the ball was thrown from back here. Oops. From back here. So if the ball was thrown from this point, this would be the other solution. Because we've kind of rescaled it by making this the new sort of datum, the new level, by making that equal 0. So t was equals 2 seconds. All right. So we know that s equals 12t, so it's going to go 12 meters per second. So if you switch it 5 for 2 seconds, it's going to go 24 meters. So that's how far away it is. 24 meters. Just 2 times t. Right, guys, I hope that all makes sense. There's 3 fairly good examples of A-level questions there, but differing kinds of the same thing, which is using those equations, using trigonometry, or solving a quadratic, just like I said at the start. As usual, have a go at the questions yourself and see if you can do them without referring to the video, and then come back to me. All right. So let's stop that and stop recording, and I'll see you soon.